Okay guys, we're going to begin looking at operators. Now if you go to the variables.py file, you're going to see that we have a section in here called numbers and math operations. And I am going to set a couple of variables here. So I'm going to say a equals 9 and I'm going to say b equals 4. Now what I want to do is I want to look at math. Now when it comes to math, the thing that we have to pay attention to is that we have a subset of options. So as an example, we have the addition operator. So if I want to do addition, I just say a plus, and then I specify a value, and it's going to actually do the math for me. Now if I wanted to assign this to a variable, I could say x equals a plus b, and then I can see the value of x is 13. So we could see the operators can be used to derive values for variables, or we could just take two variables and look at their mathematical operations. So again, if I come over here, a and b equals 13, a is still 9, b is still 4. Now the next option that I'm going to have is subtraction. So if I come over here and say a minus b, and we look at the value here, notice that it's going to come in and say it's 5. So 9 minus 4 is obviously 5. If we take a look at b minus a, notice it's going to give me a negative value. Now what I want to do is I'm going to say x equals b minus a, print x, it's negative 5, and I want to know what type of data type x is, and you'll notice it's still an integer. It's not a floating point. So if I came in and say, let's say a minus 1.5 is 7.5. If I come up here and say I want x to equal that, and then I type x, x now has 7.5, and if I look at the data type for x, it should now be a floating point. Now, addition, subtraction, straightforward. Multiplication is straightforward. So if I say a times b, I'm going to get a value of 36. If I want to do division, now division is really interesting. Now, we have two options. We have what's referred to as basic division, and we have what is referred to as floor division, and I want to entertain the two. So you'll notice that standard division, a divided by b, is going to allow me to be able to see that it is actually 2.25. However, if we were to come over here and say a, in this scenario, x equals, and then I print x, x is going to be 2.5, and if I say what data type is x, we're going to see it's a float. Now, another type of division is called floor division. Now, floor division is the default division type in version 2 of Python. And what it does is it's actually going to get rid of the decimal. So if I come over here and I repeat my math, but this time I use the floor division, which is going to be 2 slashes, and then I look at x, x is now just 2. It drops the variable. And if I say type and I look at that value, it's now an integer. So floor division is basically ignoring any remainder. So there's no decimal value or product. Now what happens if I do floor division with floating numbers? So if I do 5 dot, whoops, sorry. If I do 5, let me get rid of that dot so I don't corrupt my file. So if I say 5.5 and do floor division for 3.0, and we look at the value, what we're going to see here is that it did actually indeed result in a float. So let's go ahead and make x equal that. So we'll say x equals 5.5. 3, look at the value for x is 1.0, and if I look at the data type for x, it's going to actually be a float. So floor division with floating numbers is still going to generate a floating value. So standard floor division using integers will not produce a float. Floor division with floats will actually produce a float. And in some instances, we may want to preserve this, and we'll get into some corner case scenarios as to why. Now, the next thing that I may want to look at is how can I represent exponential values? So, for instance, if I have 2 to the third power, that's going to be 8. If I have a to the power of b, obviously 6,561. Yeah, I knew that. But the object is that these are going to be values that we need to work with, and these are called operators. Operators allow us to be able to perform math functions. Now we have an interesting one here called modulus. So if I come over here and I take a look at, say for instance, let's do floor division again. Let's do A subdivided, or floor division by B. But remember, if I did normal division, I got a value here. Well, what does modulus do? Well, floor division throws away the decimal, unless I'm doing floor division between floats. So, and it produces an integer. Well, what if I do a modulus? So if I do A, and then we take a look at the percentage symbol, which is the modulus symbol, and I do B, what we're finding here is that it's actually producing a value of 1 in this instance. So remember, A divided by B basically entered 2. Now, when we look at modulus, let's try two values. Let's say A, or 1 modulus 2. It's a 1. What about A modulus 4? It's a 1. Well, if I do 1 divided by 4, notice it's a decimal value. Now, if I do 1 divided by 1, it's whole value here. And if I do modulus, 1 modulus 1, notice it's a 0. So what's happening here is modulus is actually telling me if I have a remainder. It's not telling me what that remainder is. If I come over here and say x equals, and we say 1 modulus, actually we'll say 3 modulus, and we'll do 2, and then we'll take a look at the value of x. Notice x is 1. If I say what is the value for x, it's going to be type, it's going to be an integer, and it's always going to be 1 or 0. 1 is basically telling me that the mathematical operation I'm going to do is going to produce a remainder. That's all it's for. So it's a very handy tool. Later on we'll find out if we wanted to do operations based on even and odd. So I can actually use modulus to be able to do that. Now in the next video, what we're going to do is we're going to talk about assignment operators. Now remember, we've been using A equals something. And that says A, assign the value subsequent to the equal sign to the memory space defined by the variable. Now that causes problems in mathematics, because what if I want to look at and see if two things are equal, if A equals B? Well, what we're going to find is that I could actually screw things up. And let's go ahead and take a look at that before we dive into the actual operators. So here's what I'm describing. So if I say A equals 1 and B equals 2, and then I wanted to do something like is A equal to B? So is A equal to B? Well, what happened? Well, what happened was this. Look at A, look at B. So what I did is the single equal sign is an assignment operator. So it basically said take the variable of A and assign whatever the variable of B is to it. So when we want to determine whether or not something is actually equal, what we'll do is we use double equal signs. So is A equal to B? Yes. If I come over and say A is now equal to 1, like it was, and then I come up here and say is A equal to B? No, it's not. So keep in mind that the assignment operator is a very, very important value for us to keep our sights on when we're working with Python. And anytime that we want to do an operation that's going to be a comparative or a Boolean operation to see if two things are the same or if two things are different, what's going to end up happening is if we're looking at seeing if they're the same, we're going to have to use a double equal sign for that operation. But we'll look at that in a subsequent video. So what we're going to do now is we are going to turn our attention to this idea of assignment operators, because it's not just the equal sign. So as an example, we may want to actually increase or increment a numeric value as we produce or follow a particular loop. So if I say run the loop 5 times, I may want to actually just count the number of times that I run it, and then on that last time I may want to stop the particular loop. We haven't talked about loops yet, but they are very, very common, especially when we start utilizing Python for the purposes of doing network engineering. All right, so I'm Terry Vincent. I'll see you guys in the assignment operations video, which is to follow.